This funny little problem from I.S.I 2019 involves a little bit of geometry of polygons. Now, I'll describe the problem and then, as usual, you can pause the video and give it a try on your own. Okay, so and the link in the description will take you to clues. I mean, watching the solution is good, but well, if you can try the problem on your own and get it done, nothing is better than that. So the problem says that there are 12 sides in a polygon. It's a regular polygon of 12 sides, and we want to find out how many right triangles are possible using vertices of this polygon. It's fun to actually draw this particular polygon. It's not necessary to draw it for the purpose of this problem, but it's actually quite interesting to draw this polygon, so I will do that. Start with a regular coordinate plane, and let's call this x-axis, this one is y-axis, and I want to draw a 12-sided regular polygon. So for starters, I will just mark 4 points using I estimation, of course, which are equidistant from the origin. All right, so the origin is, let's say it's O, and I have marked 4 points on the four parts of the axis. Then we will draw 8 more points, 2 per quadrant. So it's quite easy to actually estimate that, and to I estimate and kind of draw the 12-sided polygon in this manner. Okay, now join the vertices to get the actual polygon. Now, as I told you, it's not necessary to draw the polygon to solve this problem, but I'm doing it just for fun. Now, in the meantime, you can just pause the video and try to count right triangles that can be created using vertices of this polygon. So for example, this is one right triangle using vertices of this polygon. There could be many such right triangle. All 3 vertices needs to be on the polygon's vertices. And how many such right triangles are possible? Go to the link in the description. It will have a short quiz which are actually hints for solving this problem. Maybe you can actually solve this problem on your own. It's not very hard. Okay. Now let's see how we can actually solve this problem. Well, first realize that this is actually on a circle, the vertices, right? It's not hard to prove that each of the points are lying on a circle. After all, it's a regular polygon, so it's easy to show that distance of the origin from any one of the vertices or from all of the vertices are equal. So you can take this as a radius and draw a circle, and it will pass through each of the vertices. Okay, great. So it's a cyclic polygon, and we want to find out the right triangles inside this polygon. Well, the clue is this, that one of the sides of the right triangle must be a diameter of this circle. So maybe I can just remove the vertices and draw one more time. So this is a vertex. Okay, remove the axis, that is, this is the center. So the question is, How to draw a right triangle? Well, as I mentioned, one of the sides of the right triangle must be a diameter of this particular circle. After all, if you want to fit in a right triangle inside a circle, so if this is a circle and suppose you want to create a right triangle in the circle, then one of the sides, and if the vertices are all symmetric as it is in this case of this polygon, then this larger side of the hypotenuse will be the diameter of this circle. So can you actually prove this rigorously? Can you prove this rigorously? And check the link in the description which has clues for that. Okay, so now we have diameters like this. Question is, how many diameters can we draw? How many distinct diameters can we draw? So whenever we choose a vertex, suppose if we choose this vertex, let's call it P, there is a vertex that is diametrically opposite to P. Let's call it P prime. So choosing one vertex automatically chooses the diametrically opposite vertex if you are looking for the diameter. So there are really 6 choices, right? 1, 2, 3, 4, 5, 6. Because every time you choose one, the diametrically opposite one is automatically chosen. So there are 6 choices for diameters. Great. Now for each of these 6 choices, you have to choose the third vertex. So for example, if this is your choice for diameter, you have used up 2 of the vertices. Now you have to choose the third vertex to create the right triangle. So the third vertex could be any one of these remaining 10 vertices. The third vertex could be any one using in this remaining 10 vertices. So for each of these 6 choices, you have 10 choices for third vertex. You see how beautifully geometry and combinatorics are going hand in hand. This is a very interesting, easy but interesting problem in that sense. So 10 choices for each of these 6 choices. So in total you have 6 times 10, 60 such triangles. It's beautiful. Go to the link in the description. We will give you some additional problems and a little quiz that you can try.